More factoring in section 13.4. These are some special ones. We're actually going to just have one formula that I recommend memorizing, but let's take a look at how we can reason our way through other cases. So you don't have to memorize it if you can figure it out by the same reasoning we had before. So the first one, have 4x squared minus 25. So you could think about it as there's 0x in the middle. We're going to need to have things canceling out. So let's see how we might factor this. So 4x squared, it could be 2x times 2x or 4x times x. But what I'm noticing about this, so it's special, is 4 is a perfect square, x squared is perfect square, 25 is a perfect square. So what can we do? Let's take the square root. So we're saying 2x times 2x will give us 4x squared. 5 times 5 will give me 25. And then I need this to be negative, so I need one positive and one negative being multiplied. So positive and negative. Does this work? So if I'm multiplying it, we get 4x squared minus 10x plus 10x minus 25. These middle terms cancel each other out, so we get 4x squared minus 25. That checks out. This is our answer. Notice it's kind of a symmetrical 2x plus 5 times 2x minus 5. You don't need to memorize it. You can reason your way through it. That's the safest thing. Number 2, 4x squared plus 25. Can we make this work? How can we get those middle terms to cancel? If I have a plus, I would need positive times positive or negative times negative. They're not going to cancel. Not factorable. Because I can't make the cancellation work out. So perfect squares, if they have the difference of them, we can factor it. If we're adding them, we're stuck. It's irreducible, if you like that term. Now to the fun one, cubes. This one, stand up and stretch, get your brain going, and stay with me on this one. Follow it, pause if you need to, as you want to make sense out of it. Let's try to factor this cubes. First thing is to write it as something cubed plus something else cubed. So my first piece, I'm saying 27, that's 3 cubed. And x cubed, that's x cubed. So it's 3x times 3x times 3x. That gives me 27x cubed. The last term is y that's been cubed. All right, from those pieces, the stars now are the 3x and the y. From those, we're going to be able to build our factors. How can we do that? First, we're going to factor out a linear. So we're going to take that 3x and plus y as our factor. Then we're going to figure out what we need. What is left? It's not going to be a linear. It's going to be a trinomial. So we'll have 3 pieces. What's our reasoning? I need to get 27x cubed. So 3x times what will give me 27x cubed? I need 3 times 9 to get 27, and x times x squared to get x cubed. So that's what I need in order to get my 27x cubed. Similarly, well, no. Okay, so what does that do? That picks up something. When the y gets multiplied by that, that will pick up a 9x squared y. I don't want a 9x squared y. I need to get rid of that. So how do I get rid of that? Subtract 9x squared y. But how would I get 9x squared y? 3x times what will give me that? 3 times 3 gives me 9. X times x gives me x squared, and I need a y. So that term will give me the cancellation. And so then I'd have, let's see, so this times this will give me plus 9x squared y. But it will also pick up then, actually, let me draw that on the other side. But then when the y is multiplied by that, we'll get negative 3xy squared. I need to cancel that out. So I'm asking myself here for the last term, what will give me 3xy squared? So I have my 3x times y squared will give me 3xy squared to cancel out. I made it positive. Does this work? Let's check it. So 3x needs to be distributed to all three, and y needs to be distributed to all three. So the x's, we get 27x cubed. 3x times negative 3xy is negative 9x squared y. 3x times y squared is 3xy squared. Then with the y's, I get y times 9x squared is positive 9x squared y. Y times negative 3xy is negative 3xy squared. And y times y squared is y cubed. These cancel each other out, and I get 27x cubed plus y cubed. Bam. This is my factorization. Let's look at this again. And actually, I think I'm going to put in another example before we do this one. Oops. Let's pull that out. Let's make up another example. Say we had w cubed plus 64x cubed. First thing is, let's go ahead and make this an 8. Okay, so first thing is take the cubed root. So I have 2w cubed, and cubed root of 64 is 4. So I have 2w cubed plus 4x cubed. Use your calculator to make sure you know this. So these are my building blocks. How do I build this up? So I take those building blocks first. So I have the 2w plus 4x. Then I have my pieces. So in order to get 8w cubed, I need to multiply by 4w squared. 2 times 4 is 8. W times w squared is w cubed. In order to get my 64x cubed, I need to multiply by 16 and x squared, because 4 times 16 is 64, and x times x squared is x cubed. So this will be positive. Then I have my cancellation term. What do I need to cancel? I need to have the opposite sign negative. And what I do is just take this one times this one, 2w times 4x. Well, that will be then 8xw. That will get my terms to cancel out, and you can double check. So if you like a formula, what we're doing is a cubed plus b cubed equals a plus b, a squared minus ab plus b squared. Ignore the formula if you like to reason it out. but some people like formulas. So one last example here, number 5, 8x cubed minus y to the 6. Same steps. 2x quantity cubed minus y squared cubed, right? Because y squared gives me y to the 6. So how do I parse this out? We take our building blocks, but this one we had a minus that we started with, so we're going to x minus y squared. Then, oops, not equals, times. Then we're asking ourselves 2x times what will give me 8x cubed. So 2 times 4, x times x squared. Then we're saying y squared times what will give me y6, y squared times y to the 4th. This is still positive, no change. And then we have a cancellation term. A cancellation term needs to be the opposite from this side, so it's going to be plus. And it will still be 2x times y squared. So 2xy squared. If we have a minus here, that just changes this sign and that sign. The last sign stays the same if you like formulas. So you can check this out yourself, multiply it out, and see that that comes out to be 8x cubed minus y to the 6. Enjoy. We'll see you later.